So last point is embedded software development tools. In this, the major points are different software development tools, and very important is what is the IDE. Okay, so this point is very important regarding your oral examination or industrial viva. Okay, so wherever you will go, you will require these basics. Okay, and only mugging the definitions are not sufficient, but you have to elaborate it and you have to give the practical example, okay, of all these things. Okay, so last time we have started software development tools. From my side there are a lot of problems of internet, so in this lecture I will try to cover all these points. Okay, so what we have seen last time is a difference between the host machine and the target machine. So what is the host machine we have seen? Host means, I have given the analogous example. That is, for example, right now, teacher is a host and all students are the target machines. Okay, that means what is the role of host machine regarding the software? So host machine is the machine where we have to write the embedded software. That is, we have to develop the embedded software on that machine. Okay, then you have to compile, you have to test that code, you have to debug, okay, and then optimize the code, and prior to its translation into target device. Okay, so here there are different concepts. For example, this is compiling. Okay, then what is testing, then debugging and optimization. You have used C compiler, okay, many times. From second year you have used C compiler. So optimization is nothing but you have to either you have to maximize or minimize. Okay, that means let your code is of 1000 lines. So how to reduce the size of your code? That is called as the optimization. So there are different optimizing or optimizer levels that are present in your compiler. So if you go through your C compiler or Turbo C, and in the, I don't remember the exact location, but in that you have the option of optimizer. So there are different levels, optimization at level 1, level 2, level 3. Okay, that means you can reduce the code size by different what to say, that is different ways. Okay, so in level 1, let your code size is of let 10 KB. So if you use level 1, it will becomes 8 KB. If you use level 2, it will become 6 KB. If you use level 3, it becomes 5 KB. Likewise. So there are different levels of reducing the size of your code. Okay, so that is called as the optimizations of your code. Then next point we have seen, that is a target. Okay, so what is a target machine? Target machines is a machine over which we have to load your code after the development on the host machine. Okay, so after development, the code is cross-compiled, translated into cross-assembled and linked and loaded, located into the target. Okay, so the target machine is the nothing but the machine which accept the code that is developed on the host machine. Okay, and that is copied into the your target machine. Okay, so that is called as a target machines. For example, right now as a teacher, I am elaborating all these things such that all the target audience, that is students, will understand these concepts. Okay, that means I have done some kind of development. Okay, I have developed my language, or I have developed that concept so that all my target audience or target machines will understand. Okay, so now that is what the role of the host machine. Okay, that means you have to prepare or you develop a code that is understandable and executable by the target machines. So that is what the main difference between the host and the target. Is it okay to all? So that is the first point we have seen. Then next point we have seen, that is integrated development environment, that is IDE. Can anybody explain the IDE in a simple language? Anybody who have understood the IDE? Okay, we will start from the topper. Who is the first topper?
me.
Okay, Deshmukh, so what do you understood by IDE?
It means what it provides a select from
Hello, I'm not getting the voice. Hello.
Hello.
Hello. So what is IDE? So I have told that IDE is nothing but it is an integrated environment. What is integrated? What things you are going to integrate? It's very, very simple. All the development tools like assembler, compiler, interpreter, linker, loader, debugger, all these things or all these tools are integrated in the single environment for the development of your embedded software. So that is called as a IDE. Okay, so just remember this. Don't try to by heart these things. Just understand this. Okay, so the same things are elaborated in this slide. That is, an IDE gives a single focal point for the development of your application software. Okay, so during this process, what other things are done by the IDE? So that are just enlisted. So whatever things I have told, that is, you can write your source program on editor. Okay, you have rich featured source code. Okay, you have, that means you have different features. What are the different features? I can compile, I can debug. Okay, I can put a watches. Okay, I can watch particular variables. So all these are the rich features. Then I can organize a source file into a project also, and then provision of database for many devices. What else you can do? You can compile, point out errors, and interactively correct the errors also. Okay, that is what the process of compilation that you have done on the Turbo C compiler. That is, you compile the program, and that means you are going to check the syntax, whether you have written the correct syntax or not. For example, printf. So whether you have written the correct printf or not. So this is the syntax checking, and interactively, if this is wrong, you are going to change that particular command. Then you can assemble and link to different files or applications. And last one, you link a device datasheets, user guides, and developmental manual. So that is available in the last option. Okay, in each software there is a last option is given, that is a documentation, in which they will give the information regarding your datasheets, what kind of user guides you will require, and different development tool manuals, that is how to use that software. So that kind of documentation part is also given in the IDE. So that is what the IDE. So IDE will give you all the required software tools for the development of your embedded software, as well as it will give you the documented form, so that anybody can understand how to use that softwares. Okay, so that is what about the second point, that is integrated development environment IDE. In the third point, we have started the individual tools. Okay, that is, what is the assembler, what is the compiler, what is the disassembler, what is the library, and library manager. Okay, so for this, I will take a help of website. Okay, so that is for www.jigs.org. I have taken the help. In that, they have given a very good information about all the software tools, which are also called as a language processor. So what is assembler, what is compiler, and what is interpreter. So I think last time we have completed what is assembler, what is compiler. We have not completed the interpreter. So can anybody explain compiler? What do you mean by compiler? We will go to the second topper. So Kakade is there. Or Machale. Machale, are you present or not? Okay, Kakade is also not present. Okay, both the toppers are absent today. Very good.
No, sir.
Okay. Okay, Kakade are, I think they are present. Okay, so explain what do you mean by compiler? Hello, I'm not getting voice. Okay, I can switch to uh, another students. So those who are interested, they can unmute themselves and tell me what they have understood by the compiler. Okay, do not read what I have shown on this screen. Okay, anybody? Onkar is there? Onkar Hiraman?
No,
Hello. Okay, so I'm not getting voice of Onkar also, Kakade also. I think there is a lot of problem of internet. So I will continue with myself. So what is compiler? In compiler, we will supply a source code, which is nothing but of high level language like C. Okay, so we will write a program in C on your editor, and that program is converted into a machine language, which is called as an object code. So that is called as a compiler. So compiler is nothing but the language processor that reads the, just see, that is very important, the language processor that reads the complete source program written in high level language as a whole in one go and translate it into an equivalent program in machine language is called as a compiler. So here you have to note two things. First thing is the compiler will accept input as a high level language source code and outputs you a machine language code. Okay, this is the first thing. Second thing, the compiler will read whole program that you have 1000 lines. So it will read 1000 lines at a time, and then it will compile and convert all those 1000 lines into a machine code only. Okay, so this compiler will not read the first statement and it will not convert the first statement into machine code, and then will take the second statement and then it will convert the into the machine code. Just see. So this is what the difference between the compiler and the interpreter. So in interpreter, I will go for the interpreter. That is the next one. Now what is done in interpreter? In interpreter, the translation of single, just see, the translation of single statement of source program into machine code is done by language processor and executes it immediately before moving onto the next line is called as interpreter. That means the function of the compiler and the interpreter is same, that is translate your high level language source code into the machine language code, but the way of working is different. That is, the compiler will read the complete program, okay, that is a whole program or whole source code, and it will completely convert it into the machine code in a single task. Okay, however, interpreter will work one by one. Okay, that means it will take the first C statement and convert it into the its corresponding machine code. Then it will take the second C statement, and again it will convert into machine code. So this will continue up till the 1000 line. Now this is what the basic difference between the compiler and the interpreter. Okay, so next thing is, what are the different examples of the compiler? Okay, because this is very important. That is what I have told. The elaboration and the practical example you have to provide at the time of interviews. So the practical example is C compiler is there, C++, okay, C hash, and Java compilers. Okay, now this is for the general processor, okay, or general purpose languages. Okay, now for our embedded processor, we have the C51 compiler, that is we have used the kill compiler. Okay, so now kill compiler, that is C51 of kill compiler, is a best example of the our compiler for the embedded software. Are you getting this? C, C++, C hash, Java. Okay, so these are the compilers for our general purpose languages. Okay, however, for embedded processor, we have C51 compiler of kill microvision. Okay, so that you should know. So now this is the compiler we have seen. Next is a interpreter also we have seen. Now third is software development tool that is used by the IDE is assembler. Okay, so what is assembler? Now assembler is again a simple device which will convert your source code. But now here source code is written in the assembly language rather than writing in a high level language. It is written in assembly language. That is, you have a number of assembly statement like move, AB, okay, likewise add, subtract, divide, likewise, okay, and those all assembly language code is converted into the machine language code, okay, as a object code by the assembler. So now that is what the simple function of the assembler, which will convert our assembly language code into the machine language code. Okay, I think you have got third third the third tool, that is an assembly. Now some of the good examples of interpreter are also given. Just see, it is very important again. Interpreter, what are the practical interpreter? Okay, so first example is given Perl interpreter. Second, whatever the Python we are using, okay, and whatever the MATLAB we are using, these are the interpreter. Why these are interpreter? I have told you the difference. In interpreter, we are working statement by statement. In MATLAB also, the command are executed statement by statement and not as a whole program. Okay, but in the C Turbo C, the whole program is executed in a single turn. So that is what the difference between the compiler and interpreter. So remember these examples of interpreter like Python and MATLAB. These are the good example of the interpreter. Why? Because they are working statement by statement, okay, on the your particular code. One more point is given, that is what is the difference between the compiler and the interpreter. Okay, so this question is also widely most of the time asked at the time of interview also. Okay, that is first difference already we have seen, that is what is compiler and what is the interpreter. Okay, so we'll go again one by one. So first, the difference between compiler and interpreter is that is, a compiler is a program which converts the entire source code of a programming language into executable machine code for a CPU. Just see, this is what the first difference that we have already explained. However, in interpreter, it will take a source code program and runs it line by line, okay, translating each line as it comes to it. Okay, that means it will convert each statement in high level language into its machine language. So this is the first difference. Second difference, compiler takes large amount of time to analyze the entire source code, but the overall execution time of the program is comparatively faster. That means the compilers are faster compared to the interpreter. Why interpreter is slower? Again, the reason is very simple, because interpreter takes less amount of time to analyze the source code, but the overall execution time of the program is slow. Okay, because interpreter will convert each statement in high level language into its corresponding machine level language. So this process will take more time compared to the compiler, where we are reading the complete program and converting it to the source code. Third difference is in terms of the errors. Okay, so compiler generates the error message only after scanning the whole program. So debugging is comparatively hard, as the error can be present anywhere in the program. So compiler is faster, but however, it has to deal with the errors. Okay, that means it is very difficult to find the errors in a 1000 line source code, because it will read all 1000 line in a single turn. So it is very difficult to find a bug or the error. However, in interpreter, since we are executing each statement by statement, so debugging and finding the error is very simple. Okay, so that is what the advantage. Next, your compiler will generate intermediate object code. Okay, I think you have studied in system programming what is intermediate object code. Okay, so here it will generate intermediate object code. However, However, in interpreter, no intermediate object code is generated. Okay. Simple example, last difference is given. That is, different examples of compilers are C compiler, C++ compiler, Java compilers. Okay. However, in interpreter, you have Python, Perl compile interpreter, and MATLAB interpreter. Okay. So at least you should remember the difference between compiler and interpreter and the definition of assembler, compiler, and interpreter. So those are very important regarding your oral examination. Now next point. Okay. So here you can see the slide, I think. Okay. Is it visible? I think this slide is visible to all. Is it visible?
Yes, sir.
Okay. So here, if you can observe in the compiler, I have given the example because we are interested in developing the embedded software and not a general purpose software. So we should have a compiler which is compatible to embedded software and not for general purpose language processors. Okay. So here examples are given for embedded processor, that is C51 compiler from Keel and GCC compiler. You remember this GCC. I will bet on this GCC. You will be asked the question on this GCC anywhere. Okay. In your career, this GCC is used in most of the compilers or in IDE. Okay. It's a very standard compiler that is used. Then CPP that I already told you, but these are not used for developing the embedded softwares. Next software tool is called as a disassembler. Okay, so it will do the reverse, that is of assembler. Disassembler means assembler will convert the assembly language into the machine code. Now it will convert or it translate the object code into mnemonics form of assembly language. Okay, that is disassembler. It will do the reverse operation compared to the assembler, that is from machine or object code to the your assembly language, that is in terms of numeric. So that is what the software tool called as a disassembler. Then library and library manager. No need to tell about library. We have always include standard input output libraries, math libraries. Okay, then string libraries likewise. So all those are the libraries that we need for the proper functioning of our code. So an ordered and specially formatted program collection object code is called as a library, so that a linker can use. Okay, means this code is already written so that we can use it for the proper execution of our main program. So that is called as a library, and for this library there is a library manager also. Now this is very interesting. Next point is cross assembler. Okay, so already we have seen the definition of cross assembler. Okay, the definition of assembler. Now what do you mean by cross assembler? Okay, so I think 99% students or peoples will not aware about the cross assembler and the cross compiler. Okay, no one. Okay, because we are not getting with these kinds of concepts. So what is cross assembler and cross compilers? In the name itself they have given, but first of all you have to understand the difference between the host and target machine. That's why I have told or I have explained the host machine and the target machine. So what is done in the cross assembler? So I will read this statement and again I will explain the meaning of the cross assembler. So an assembler that runs on one type of computer and assembles the source code for different target computer is called as a cross assembler. Are you getting? Okay, I will read it one more time. An assembler that runs on one type of computer and assembles the source code for different target computer is called as the cross assembler. Okay. Now I will give you a simple example, that is this one. That is, I have an assembler that runs on an Intel 86 platform, that is you have 8086 microprocessor, okay, and it will generate object code for Motorola 68HC05, okay. So here you have to note that 8086 is one processor and 6800 is another processor. Means there are two different types of processor from two different companies. First is from Intel, second is from the company Motorola, okay. So I have two different processors from two different companies. Now next thing is, the first question is why to use cross assembler? Okay, means what is the need of cross assembler? The need of cross assembler, why this is necessary to develop. Let you have written a code on 8085, 8051 microcontroller. Okay, that is already you are familiar with 8051. Okay, so you have written one code for 8051 process, microcontroller. Okay, and after some months you are interested to replace that 8051 with a peak microcontroller. Okay, so what are the different changes you have to made into the software? So that is very important thing now. Okay, so cross assembler is used to convert your code written for one processor or microcontroller, okay, so that it is compatible to the another processor also. Okay, hello, are you getting or not? The cross assembler or cross compiler is a software tool, okay, used to make your code compatible to the another machine. Okay, for example, I have written some code on my machine, okay, and my machine uses the 8051 microcontroller. Now whether this code is compatible to the another machine which uses the PIC microcontroller, is it compatible directly? Can I use the same source code, okay, that I have used for 8051 microcontroller, okay, and I have to use the same code for the PIC microcontroller? Can I use the same code? Anybody? Hello. My question is very simple. I have written a source code. I have written a source code on a machine which uses my 8051 microcontroller as my processor. And now I want to use the same code for the another machine which having another processor, that is a PIC microcontroller. So is it possible to use the same code on the another machine or not? Hello. Try to unmute other people's. Okay, sir. Getting disturbed. I don't know. So at least give the answers. Unmute yourself and give some answers. Anybody? Okay. Omkar has given the answer. No, sir. Okay. Is there any answer? Other answers? Okay. How much time I have left? Okay, the session may be discontinued. Okay, try to again log in. So what is cross assembler? Just see, I have written a code. I will again try to make you understand that I have written a code on my machine. My machine is my machine uses the 8051 platform. Now I have to use the same code to the another machine. Now that machine is going to use only the PIC microcontroller. Okay. So how to make my code